Hello, rising fifth graders. I'm happy to provide you for the first time with official mathematics instruction as your teacher. The school year hasn't begun yet. As I record this, it's July 11, 2022. We still have a good deal of summer vacation left, but we're going to get a head start. Sometimes I'm asked, or sometimes I have an opportunity to describe what I do in teaching middle school mathematics, and particularly for grades 5 and 6, I usually answer that question with one word, and that is fractions. Please, I want to say right from the start, do not be intimidated or scared of fractions. Once we define what a fraction is, which we're going to do now, everything else that comes will flow from that definition in a logical way. That's what mathematics is about. We make certain assumptions that we can all agree to, or we define things. We say, okay, it's going to mean this. And we work from there through reasoning to build the structure of mathematics. I have my part to play in that process, but so do you. Your part is even more important. You have to construct that knowledge for yourself and always be adding to the story in a way that makes sense to you. And if something doesn't make sense, it's your responsibility to bring that not just to my attention, but to the attention of the entire class. Chances are very good that if you have a question, other students will as well. So please ask those questions when necessary. So, what is a fraction? Before we answer that question, I want to go back to a couple things you certainly know. How about this? Now, we all know that, but believe it or not, to explore what this means is going to help us with the second part of today's video when we are called upon to add and subtract fractions with the same denominator. The question you automatically have from that, I'm sure, is, well, what if the denominators are different? And there's an old saying, Rome wasn't built in a day. We're going to be on a journey. Some things we just have to wait to get to so we can make that road, construct that road that will get us to those more advanced topics. Don't worry. Don't worry about the fact that you don't know how to add fractions with different denominators, because you will. Because you'll work at it and you'll understand it. You'll build the story for yourself. I think a word right now about this word, for me to say something about this word, or these two related words, might make sense. I read a saying a few years ago in a book about math, not a textbook like you use, but a book that was written for math teachers to talk about how do we teach this wonderful subject to students. And I don't know who it was, but it's a wonderful saying, and it goes like this. Symbols are to math what water is to swimming. Now that's called an analogy when you compare two different things, math and swimming. But how does water relate to swimming? Well, it's what we swim in. And symbols are what we do math in or with. And there are two of them. Well, these squiggles here, this and this and this, that we call numbers, single-digit numbers, those are symbols. This stands for quantity, this many things. This stands for the quantity of this many things, and this symbol here stands for that many things. Here's another symbol. What does it mean? We know that's addition. What does it mean? And there's another symbol. How many does that make? Five symbols there. The equal sign. And often in math, our understanding of symbols develops, changes over time. We understand it in a different way, a more more meaningful way later on. Let me tell you right now, the equal sign does not mean, here comes the answer. And if you, right now, you think that's what it means, that's fine. That's usually how young people think of the equal sign. Here comes the answer. But what it really means is that whatever's on the left, whatever's on the right, are the same point on the number line. Now, I'm going to assume you've had some exposure to the number line. The number line is one of the most important tools that we have for the understanding of math. And it will be with you throughout your mathematics journey. Throughout your journey here in middle school at St. John's and into high school and into college, the number line is present in math to a great, great degree. The more you become familiar with it, the better you'll be. This number line here, I chose a point. I happened to choose it on the far left, and I called it 0. I went a certain distance, put a mark, put a point. I'm using little slashes, little hash marks here, because they're easier for you to see. Sometimes you just make a little circle like that. These are infinitely small points on the number line. That's a geometric concept that we'll explore more later. But all of these points on the line that are numbers, those points are infinitely small. Once we choose a 0 and a 1, everything else comes from that, because we go the same distance again and call it 2, the same distance again and call it 3, the same distance again and call it 4, and so on, forever, to infinity. Before I started this video, I took a meter stick and I equally spaced those whole numbers. These are the first 9 whole numbers, 0, 1, 2, 3, those are the whole numbers. And the whole numbers are what we work with when we're very young in school. And once we get to middle school, we start to formally deal with another kind of number known as fractions. So let's get into now the definition of fraction. Well, this idea of equally spacing the whole numbers is going to evolve into how we define a fraction. So let's say that I take the spaces between each of these whole numbers and divide each of those spaces into 2 equally sized spaces. How would I do that? How do you think you'd do that? I want to divide this distance from 0 to 1 into 2 equally sized spaces. Well, wouldn't I put a point, we'd say, in the middle? Now, I'm not going to use a ruler here to save time. I'm going to eyeball it, but it should work out to be okay. Now notice, I only had to put one point halfway between 0 and 1 to create those 2 equally sized segments or pieces. There's one here, and there's one here that are now the same length. That one point creates 2 segments or pieces of the unit. The distance between 0 and 1 is called the unit, and it's the same between 1 and 2 and 2 and 3 and so on. So I will now put a point halfway between each of these whole numbers, and it's easy to see that this could continue forever. The number line that contains the whole numbers, or the ones, the whole numbers could be called ones, and then of course you get to tens and hundreds and so on. That's infinitely long. What we now have is a halves number line, and that's infinitely long. It can go forever. We could have a point halfway between 999 and 1,000, and that would be 999 and a half. I'm getting a little ahead of myself. But this is the first step in understanding what fractions are. Now, there's an unfortunate language issue here. When we divide the unit into 2 equally sized pieces, we don't call them tooths, because that sounds weird. We call them halves. And if we were to create a number line where the unit is divided into 3 equally sized pieces, we don't call that a 3ths number line. We call it a 3rds number line. But once we get to 4, for the most part, we're going to name that fractional number line with a THS on the end. So if we divide the unit into 4 equally sized pieces, it'll be called a 4ths number line, THS at the end. Then a 5ths number line we could construct, a 6ths, a 7ths, and the THS like that is most of them. There are a few exceptions, like if we were to create a divide the unit into 21 equally sized pieces. We probably won't do that, but 21 equally sized pieces, we wouldn't call that a 21ths number line because it sounds weird. We'd call that a 21st number line. But for the most part, this way of naming the number line really is all about the denominator. Now you know that a fraction has a fraction bar, and then a number on the top called the numerator, and a number on the bottom called the denominator. And it's nice to know those names, but it's even more important to know what they mean. The bottom number, the denominator, it tells us how many equally sized pieces the unit, the distance between each whole number, has been divided into. And in this case, this is a halves number line, so the denominator is 2. What's the role of the numerator? That's simpler, I think, because the numerator, you can kind of see the word number in there. The numerator just is a counting thing. The numerator counts how many of these halves we have as we go from left to right, starting at 0. We simply count the halves. That's all the numerator does. So the denominator tells us how many equally sized pieces to divide the unit into. Unit is the distance between 0 and 1 and 1 and 2 and so on. And the numerator simply keeps track of which one. But here's an important thing. The whole numbers that were originally on that number line are also now going to be halves. Every point on that number line is going to be a half, one of the halves. And we're simply going to count them. The first half to the right of 0 is 1/2. And this number here, which is 1, is also a half. And which half is it? It's the second half to the right of 0. Notice what we're doing here. We're simply counting the halves, which include the whole numbers. I can't emphasize the importance of that enough. But watch how simple this is. 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves. Look at the numerators now. Well, the denominators are all 2, because that's the kind of number line that it is now. And the numerator is simply the whole numbers. 1, 2, 3, 4, 5. Let me circle the halves so they're easier to see. And then the whole numbers that were there originally, I'll just leave those alone. Okay? 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, and so on. Now, I just erased 2 plus 3 equals 5. And I talked about the fact that there were symbols there. And I said the equal sign does not mean here comes the answer. The equal sign means whatever's on the left is the same point on the number line as what's on the right. The left and the right side of the equal sign are the same point on the number line. So when we start to define a fraction, the first thing we say is, A fraction is a certain point on the number line. Well, which point? How do we determine what that point is? The denominator tells us how many equally sized pieces to divide the unit into, and then the numerator just tells us which one it is as we count from left to right like we always do. 1, 2, 3, 4, and so on. Let me put that 2 plus 3 back up on the board. And so we're going to get into adding fractions with the same denominator. But what I want you to understand is it flows directly from our understanding of adding whole numbers. It'll just be that instead of adding ones or whole numbers, we're adding halves or thirds or fourths. And depending on the time that gets used up, we'll look at thirds, and then we'll look at fourths to make sure we understand this definition of fraction, what it is, and also to explore how to add and subtract fractions with the same denominator, which is very simple. But let's make sure we understand adding two whole numbers. 2 plus 3 equals 5. Well, start at 2 and then count on. Did you use an expression like that in the lower grades? Go to 2, count on from 2, 3 more. So here's 2, and then we want to count on 3 more. Now, ignore the halves for now. I'm just going back to the whole number. 1, 2, 3, and of course we end up at 5. So this idea of combining the 2 and the 3, starting at 2 and counting 3 more, lands us on the 5. So this collection of symbols here, 2 plus 3, is the same point on the number line, that's what the equal sign means, as 5. That's very simple, but it's crucial to keep that in mind when we talk about adding fractions. Should we add some halves now? Let me erase this. 2 plus 3 equals 5. And let me show you how so incredibly similar it is to add fractions. How about if we add 3 halves and 5 halves? Okay, well now we do have to focus on this entire halves number line. We can't restrict ourselves to just the whole numbers because we're adding halves. I bet a lot of you know what 3 halves plus 5 halves is. If we start at 3 halves and we count, add on, what is it? What's that expression? Count on. If we count on from 3 halves, 5 more halves, where are we going to be? Won't we be at 8 halves? I'll show that, but doesn't that make sense? It's just like adding whole numbers. 3 halves is here, so just like before, we'll start there, and then we'll count on. What are we going to count on by? By 5 halves. So this time, when we make that jump or that step, 5 steps, it's going to be 5 halves. And each of those points on the number line is a half, including the whole numbers. So the first step that we take, we're going to count 5 more halves from 3 halves. The first step brings us there. So that's 1 more half beyond 3 halves. And then 2 halves, 3 halves, 4 halves, and 5 halves brings us there. Now, you should notice that 8 halves is the same as 4, and we can't do everything at once. Early on, whether it's through some videos this summer or early when we're actually back to school, we're going to talk about the fact that 8/2 is the same point on the number line as 4. So we could also say here that the answer is 4. 4 ones, or simply 4, because 8/2 and 4 are the same point on the number line. So notice again, notice that. What does this equal sign mean? It doesn't mean here comes the answer. It means 8/2 and the whole number 4 are the same point on the number line. Let's look at thirds next. Let me ask you this question. If I want to create a thirds number line right on top of this whole number line that goes from 0 to 7, how many equally sized pieces am I going to divide 0 to 1 into if it's a thirds number line? 3, right? How many points do I need to make between the 0 and the 1 to create those 3 equally sized spaces? The answer is 2. You always have one fewer point between each whole number than you do spaces. The 2 points create 3 spaces, and 3 points create 4 spaces, and 4 points create 5 spaces, and so on. And again, I'm going to rely on my ability to eyeball it. Hopefully it'll look okay to save time. And I'm going to put a point. First of all, I always find that when I finish one of these videos and look back at it, even though I'm using a new marker, it looks pretty clear to me. And if you were in the room, you'd see it. But for some reason in the videos, I got to be careful that you can see everything. So I'm going to put 2 points here and here. And hopefully I eyeballed that pretty well so that, let me just, before I continue, we think of it like this. 1, 2, 3. This line segment here, or that space, and this line segment and this line segment are supposed to be exactly the same length, exactly the same size. And we take these steps. When we take these steps on a thirds number line, each step is 1/3. And once again, notice, the whole number 1 is one of the thirds. It happens to be the third third. The whole number 2 is going to be one of the thirds. All the whole numbers are also thirds. That's extremely important. So here, and here, here, and here, here and here, this and this, 2 points, making little hash marks. We generally call them points, and they're infinitely small. 2 points between each whole number makes a thirds number line. That's what the denominator means. The denominator, so that's what this number line is all about now. It's a thirds number line, meaning the denominator is 3 because each whole number length, each unit, has been divided into 3 equally sized pieces. This is the definition of fraction. And this symbol here, which we call a fraction bar, nothing fancy, just known as a fraction bar. And we're usually not going to talk about it, but it's just there to help our eyes distinguish between the numerator and denominator. I guess if we were used to it, if we just put one number on top of the other, I guess that could work for fractions, but just to help us see it a little better, the tradition has been to have that fraction bar there. And what does the numerator do? Well, the numerator keeps track of which third we're talking about, and we simply count them the way we count with whole numbers. So the first third to the right of 0 is 1/3. The second third to the right of 0 is 2/3. It's as simple as that. And the third third to the right of 0 is 3/3. But notice, we already called it 1. So as far as this same point on the number line, 3/3 equals 1 because it's the same. 3/3 is this point right here, and that point right there is also 1. Same point on the number line. A fraction is a point on the number line, a certain point on the number line, and we get to it or identify it through the denominator telling us how many equally sized pieces, and then the numerator simply counting them, starting with 0 and going to the right. 4/3, 5/3, 6/3, and let me circle the thirds again. And notice, of course, 3/3 is 1, and 4/3, 5/3, 6/3, which is also 2. Then comes 7/3, and then 8/3, no surprise. There are absolutely no surprises. You see, that's another thing that I read from a mentor of mine, somebody who's given me a lot of instruction. I've never met the gentleman, but through reading his books and articles, this is one of his main messages that he advises us teachers to get across, that there are never any surprises in math. Everything flows logically, reasonably from what we've learned before. The assumptions we've made, the definitions we've made, and so on. 8/3, then comes 9/3, which is also 3, 10/3, 11/3, 12/3, and so on. To be honest, I think math is extremely exciting and interesting, but this is getting a little boring, don't you think? Well, substitute the word easy for boring. It's incredibly easy. Oh, by the way, let's write this. 6/3 is 2, and 7/3, I'm sorry, not 7/3, 9/3 is the whole number 3. Now, students often have trouble with this at the very beginning because they're not understanding that when I write this 2 here, it means the whole number 2 that you're all familiar with, right? This here is the fraction 6/3, but it's the same point on the number line as the whole number 2. How about adding some thirds? Should we add some thirds? And maybe now's a good time to talk about subtraction as well. So how about 2/3 plus 2/3? Go to 2/3, which is here, and count on by 2 more thirds. So making steps, and each step is 1/3, and we go 2 of those steps. Start at 2/3, and then count on by 2 more thirds, 1/3, 2/3, and we'll be at 4/3. Now, I didn't say this earlier with halves, but notice what we're not doing when we add fractions. What are we not adding? And I'll add this. What do we never add? We never add the denominators. It doesn't make sense. The denominator tells us what we're counting. Don't add the denominators. 2/3 plus 2/3 is 4/3. Now, some of you might recognize, or have learned before, that there's another way to talk about 4/3. There's another way to identify it. When we write 4/3, we mean it's the 4th third to the right of 0. Okay? Just by counting. There's 0. 1/3, 2/3, 3/3, 4/3. Simple. The 4th third to the right of 0. But isn't it also 1/3 past 1? Well, here's the whole number 1. Right? The original whole number line. This point right here is 1. And the 4/3 is 1/3 past the 1. So I think you know what's coming. We have this thing called a mixed number. It's not the best name. It's called mixed because it's a mixture of a whole number and a fraction. There's a glare there. I hope you can see that. It's 1 1/3. Notice that when we say a mixed number, we say the word and. And indicates addition. What is 1 1/3? Well, we don't write it this way, but it's simply 1 plus a third. So you go to the whole number 1 and go 1/3 to the right. to land on 1 1/3, which is also 4/3. I'm planning the second video for this summer to be talking about just that subject of mixed number. How do we go from something like 4/3 to 1 1/3? Don't be intimidated by it. It makes perfect sense. 4/3 is the fourth third to the right of 0. 1 1/3 is the first third to the right of 1. And they're the same point on the number line. Once again, right here. What does that equal sign mean? These are the same point on the number line. They're both right here. That point is 4/3. It's also 1 plus 1 more third, 1 1/3. Subtraction. Well, you learned in the early grades that if you are subtracting, you start at a number and then you move to the left. You count backwards. Right? When you're adding, you count on to the right. When you're subtracting, you count backwards. You take 2 steps to the left from the 5 as whole numbers, right? So we gotta go back to that whole number line. Okay, so here's 5, and then if we're subtracting 3, we take 3 steps of 1 each, 1 whole each. So we go back to 4, that's 1, and then to 3, that's 2, and then here is 3 ones to the left of 5. So once again, this equal sign does not mean here comes the answer. It means that when we define subtraction as starting at one point and then moving to the left by a certain amount, we land somewhere. So this symbolism here, 5 minus 3, and this symbol here, 2, is the same point on the number line. It's this one right here, right? Very similar to addition, except we'll move to the left. And the subtraction of fractions works in the same way. So let's say we want to do 11/3 minus 4/3. What do you suppose that is? I'll tell you what it's not. It's not 7 over 0. You can never have 0 in the denominator. That's another matter. But the point I'm making is you don't subtract the denominators. You never add or subtract the denominators. It doesn't make sense. The thirds are what we're counting. So, and addition and subtraction are just an advanced way of looking at counting. So what does this mean? Start at 11/3. Here's 11/3. And since we're subtracting, we're going to move to the left by 4/3. And now, before when I did 5 minus 3, I was jumping by ones, by whole numbers. But now I'm going to jump by thirds. I'm subtracting thirds. So if I start at 11/3, I now want to move to the left by 4/3, or 4 jumps, 4 steps. 1, 2, 3, 4. And that point, I previously counted, when I made the thirds number line, I counted the thirds, and that point right there is 7/3. So there it is. Simple. 11/3 minus 4/3 is 7/3. Notice we're building on whole number concepts, whole number addition and subtraction. If we want to be very specific, we can say 11/3 minus 4/3 is 11 minus 4/3. And what is that? That's a whole number subtraction, right? So there it is as 7/3. Now, this next thing I'm going to do to close out this video, we're already almost 35 minutes. So I am going to close off, and then there'll be a part 2. But here's a preview of part 2. I already did it with 4/3 a moment ago, when we looked at 4/3 and saw that it's 1/3 past 1. So we call it 1 1/3. Well, what about this 7/3? okay? Well, here's the whole number 2. Right? That point right there is the whole number 2. 7/3 is 1/3 to the right of the whole number 2. So we can call it 2 and 1/3, that mixed number. And by the way, this kind of fraction here, where the numerator is greater than the denominator, also has a name. It's called an improper fraction, which is not a great name, because improper fractions are perfectly good numbers. There's nothing wrong with 7/3. 7/3 is the answer to that subtraction. It's not wrong. But it's also 2 and 1/3. We sort of have a preference for expressing the answer as 2 and 1/3, which, again, is an understood plus sign. We don't write it, but we say and, right? So 7/3 is 1/3 past 2. It's the whole number 2 plus another third, which you can see from the number line. There's 2, and there is the 7/3, which is 1/3 past 1/3 past 2. You know, the thing about math, once you get started, it's hard to stop. There's always something else you can head toward. And my job is to explain all of those steps that we take along the road clearly. Your job is to make sure you understand it clearly and let everybody know. Don't be afraid. The only bad question is the one you don't ask. Don't ever be afraid of asking a question. I can almost guarantee that if you have the question, someone else does, or several people do. And even if you're the only one, that's okay. Try to get everybody to the same place along the journey. And you know, I have to think about the pacing and the fact that we can't do everything at once, but sometimes I just can't resist. So we saw here that 11/3 minus 4/3 is 7/3. Very, very simple, very obvious. Maybe this is a little bit more challenging of a concept, and we'll deal with it more in the next video. But if this answer here was a mixed number, what about these two numbers that I started with? And I knew when I wrote them that they could be mixed numbers. But, you know, keeping things simple. 11/3 minus 4/3, very simple. But this 11/3 here, this point, is 2/3 past 3. We're going to get into more of the details about this. But 11/3 is 3 and 2/3. Okay? And this 4/3, we already saw earlier that 4/3 is 1 and 1/3. So let me ask you this. Does it make sense to you that 3 and 2/3 minus 1 and 1/3 is 2 and 1/3? Does that make sense? I think it might. Right? Sometimes when we're doing these so-called mixed number additions and subtractions, we set them up vertically like this. And we go, 2/3 minus 1/3 is 1/3. Subtract the thirds, right? And 3 minus 1 is 2, and there's the 2 and 1/3. If at any point, not just now, but at any point along our journey, you don't understand something, let me know. In terms of this video and the next one to come, you can always pause or go back and replay something, and maybe the second time you play through, say, I get it now. When you have that moment, I get it, I understand it. That's what you should always be striving for. You make a decent effort, and it doesn't happen. When you're in class, you raise your hand and ask a question. For now, over the summer, send me an email. Try to describe. You could say, you know, at 27 minutes and 30 seconds you said, or please explain this, and I'll do my best. It's kind of limited what I could do by email, but I'm happy to try. Please email me if you have any questions. even questions about things to come. I might say, well, that has to wait, or maybe I'll give some kind of an answer, but I'd love to hear from you. We can establish a relationship this summer through these videos and through email. That's part of the point here. Get a little bit of a head start. We are going to be making the journey together, so we might as well establish that relationship of relating to each other about the math, talking about the math, thinking about the math. So I'll call it quits for now, and I'm planning a second video for this summer where we get more into this idea of this so-called mixed number here. Okay? Enjoy the summer, and I'll see you soon on YouTube. And actually, it'll be fairly soon when we're together in the classroom. That's going to be even more exciting. So long for now.